Okay, let's get into something really fundamental for Node.js developers. How does your Node app actually talk to the rest of your computer? Like, run other programs?
Right, yeah. That's where the child process module is key. It's basically Node's way of starting up other processes.
So these are like little helper programs running alongside the main Node application.
Exactly. Think of it like delegation. Your Node code can tell the operating system, hey, go run this shell command or execute this other script for me.
Makes sense. And child process gives us a few ways to do that depending on what we need.
Yep, several tools in the toolkit. Each one's got its own kind of strengths.
Okay, so let's say I just need to run a simple command, something quick like, I don't know, listing files with Ls or checking disk space.
Yeah, for those kind of common, straightforward tasks, exec is often the first thing people try.
Got it.
And the interesting part about exec is that it runs your command inside a shell.
Ah, a shell. So it
Mhm.
understands things like pipes or maybe chaining commands with enda, things you'd normally type in a terminal.
Precisely.
Yeah.
So if you wanted to do something like, else icell grep some file, exec handles that naturally because the shell understands the pipe. Super convenient for those cases.
Okay, convenient, but I feel like there's usually a but. What's the catch with exec? I seem to remember something about output.
You got it. The main thing with exec, especially thinking about Node's event loop and memory, is buffering. It waits and collects all the output from the command.
All of it in memory.
Yeah, all of it. It buffers the entire output before it passes it back to your Node code in a callback.
Ooh, okay. So if that command dumps out like a gigabyte of logs,
Then you've got a potential problem. Yeah. Your Node process might run out of memory trying to hold all that data at once. Not great for big outputs.
right, that makes sense. And the shell thing.
Yeah.
That sounds like it could be a security risk too if you're not careful with user input, like shell injection.
Absolutely. If you construct the command string using input that could come from a user, you have to be super careful about sanitizing it. Otherwise, someone could potentially run nasty commands. So exec is simple, but yeah, limitations.
Okay, so exec is good for simple things, small outputs, but maybe not for long-running stuff or huge amounts of data. What if you need that? Like processing a massive file.
Ah, well, that's exactly where Spawn comes in. It's designed for those scenarios.
Spawn. How's it different? Does it avoid that buffering issue?
It does. That's the key difference. Instead of waiting and buffering, Spawn gives you streams.
Streams, like start and starter.
Exactly. Standard input, standard output, standard error. You get access to the data as the child process produces it, chunk by chunk.
Ah, like streaming a video online instead of downloading the whole thing first.
Perfect analogy. You can process the data as it comes in. Much better for memory if the output is large, and essential for processes that might run for a long time, or even indefinitely.
And does Spawn use a shell by default?
Nope. It executes the command directly, which means you don't get those shell features like piping quite as easily. You'd have to handle that yourself. But
But it's safer. Less risk of shell injection.
generally, yes, because you're usually passing the command and its arguments as an array, not one big string for a shell to interpret. So Spawn is often the go-to for efficiency and potentially better security, especially with complex or long-running tasks.
Okay, so exec for simple shell stuff, Spawn for streams and long processes. What about Xfile? I've seen that one too.
Right, exec file is sort of a middle ground, or maybe more specific. It's like exec in that it buffers the output.
Okay, so same potential memory issue for large outputs.
Correct. But like Spawn, it does not use a shell by default. It
Yeah.
executes a specific file directly.
So more secure than exec if you don't need shell features, but still buffers. When would you use that?
Maybe when you know the exact path to an executable, the output is definitely going to be small, and you want that direct execution without the overhead or potential risks of a shell. It's a bit more efficient than exec because it skips the shell step.
Gotcha. Exec, spawn, exec's file. Now there's one more, right? Fork. That one seems kind of different.
It is, yeah. Fork is really special. It's actually a specific type of spawn, but it's designed only for running other Node.js script.
Ah, node to node, so you fork another JS file.
Exactly. And when you do that, the child process gets its own node runtime, its own memory, its own event loop. But the key thing, the really powerful part, is that fork automatically sets up a communication channel between the parent process and the child node process.
An IPC channel, inter-process communication.
Yep, built right in.
Hmm.
This means the parent and child can send messages back and forth, not just strings, but like actual JavaScript objects.
Whoa, okay. Why is that so useful?
Well, think about Node being single-threaded. If you have a really heavy CPU-intensive task, It can block the event loop, right? Makes your whole app unresponsive.
Yeah, definitely want to avoid that.
So with fork, you can push that heavy task off to the child process. The child churns away on it, using its own resources, its own event loop. And when it's done, it just sends the result back to the parent over that IPC channel. The parent's event loop stays free.
That's brilliant. So fork is the way to leverage multiple CPU cores with Node, basically, by creating separate node processes that can talk to each other easily.
Pretty much. It's a core pattern for scaling node applications on a single machine or handling those blocking tasks gracefully.
Okay, this clarifies things a lot. We've got
Yeah.
spawn for streaming I/O, great for large data or long tasks, no shell by default, exec for simpler tasks, uses a shell, buffers output, exec file, like exec but no shell, direct execution, still buffers, and fork specifically for node-to-node communication via IPC.
That's a great summary. Understanding those distinctions, shell versus no shell, buffering versus streaming, and that special IPC with fork is crucial for picking the right tool. It really comes down to how you need your main process to interact with other processes or the system.
Right. It's all about choosing the best way to delegate work, which leads to a bigger thought, really.
Yeah.
If your app can now spin up and manage these separate processes, how do you actually architect that effectively? How do you handle the communication, make sure they coordinate properly, and what happens if one of these child processes fails? How do you build a system that's robust when it's made of these independent parts?